As I mentioned when we learned about circles, every one of these graphs that we're going to learn about have a geometric definition to them. The circles is super easy. All the points equidistant from a single point. The rest of them get a little bit more complicated, and I want to try to give you some different context to try to visualize it. The first one we're looking at here is a parabola. And what a parabola has is it always has a point, point A. This point is called the focus. And from that focus, we're going to measure the distance to the parabola. And because there is an infinite number of points on the parabola, it's going to be different depending on where that point is. So I've put a point B on the parabola. As I move B around, you can see that the distance AB changes throughout. Well, it turns out that not only is there a focus, there's also a line that is important. And that line I've drawn in. And it is y equals negative 0.25, and I'll explain that at a different video where those numbers come from. But what is true is if I measure the distance from this point on the parabola to the line, that distance will always be the same as the distance from that point to the focus. So notice that no matter where I do it, it is always the same. And please understand that the way that you calculate the distance from this point B to the line is at a perpendicular. And so that's why the distance is changing because of that perpendicular. We could have this this works for any parabola. So for example, let's change it to a parabola that looks like this. And so we'll do this one divided by 4. So a much wider parabola. If you do that, it turns out that the relevant line is y equals -1, and the relevant point is 0, 1. And so now when I look at my distances, let's go find the point really quick. Where did my point go? The distance between, well, you can see the two distances there. There's my point B. And so if I start moving my point B around, you can see that those distances still remain the same because I picked the appropriate point, the focus, and the appropriate line, which is referred to as a directrix. And so every parabola is going to have this property, and then this property is going to be how we're going to come up with our general form of a parabola.